Hello everyone. Today we are going to learn the next measure of central tendency, name is deciles. First of all, we see the definition of deciles. D1, D2, D3, D4, D5, D6, D7, D8 and D9 which divide the data into 10 equal parts when data arranged in ascending or descending order. In last lecture, we already learned the term quartiles. What is the quartiles? There are three quartiles Q1, Q2, Q3 which divide the data into 4 equal parts. Similarly, there are the 9 deciles which divides the data into how many equal parts? 10 equal parts. Okay, but we need to arrange the data in ascending or descending order to find out the values of deciles. Now see case 1. For ungrouped data, what is the formula? Di is equal to I in bracket n plus 1 divided by 10th observation when data arranged in ascending or descending order. Here the value is 10 because the deciles, 9 deciles which divide the data into 10 equal parts. In quartiles, here the value is 4 instead of 10 and in median the value is 2 instead of 10. Okay. So now see example. Calculate D5, D6 and D9 for following data. The data we are given 26, 30, 35, 5, 6, 7, 9, 20, 40, 45, 11, 18, 15, 49 and last is 60. So to find out the deciles, we need to arrange the data in ascending or descending order first. So ascending order data is 5, 6, 7, 9, 11, 15, 18, 20, 26, 30, 35, 40, 45, 49 and last is 60. We are given the total 15 observations. So here the n value is 15. Now just for finding the D5, first put the I value is equal to 5 in the formula. What is the formula for finding the deciles value? Di is equal to I in bracket n plus 1 divided by 10th observations when data arranged in ascending or descending order. So here put I is equal to 5. So formula is D5 is equal to 5 into n plus 1 divided by 10th observation when data arranged in ascending or descending order. Now plug n is equal to 15 in the formula. So 15 plus 1 divided by 10th observations. So 15 plus 1 divided by 10th observation, that is 16 divided by 10. So 16 divided by 10, that is 1.6. So 1.6 into 5. So 8. So 8th observation. So which one is the 8th observations here? So 20 is the 8th observation. So here the D5 value is 20. Okay, now see how to find out the D6, that is 6 deciles. So for finding the D6, put I is equal to 6 in the formula. Okay, what is the formula for finding the deciles? Di is equal to I in bracket n plus 1 divided by 10th observations when data arranged in ascending or descending order. Put I is equal to 6. So 6 into n plus 1 divided by 10th observation. Now put the n value is equal to 15 because we are given the total 15 observations. So 15 plus 1 divided by 10th observation. So 15 plus 1, that is 16. 16 divided by 10th, that is 1.6. So 1.6 into 6, that is 9.6. Okay, so how to find out the 9.6 observations? So 9.6 value is written as 9 plus 0.6. So first digit is 9. So 9th observation plus remaining part as it is 0.6 in bracket. After the 9th observation there is the 10th observation. So 10th minus previous observation, that is 9. Now just plug the value of 10th observation, 9th observation in the formula. So which one is the 9th observations in given series of data? So 9th observation is 26. So 26 plus 0.6 as it is. So which one is the 10th observation? 10th observation is 30. So 30 minus 26. Okay. Now 26 plus 0.6 into 30 minus 26, that is 4. So 0.6 into 4, that is 2.4. Okay. So 2.4 plus 26, that is 28.4. So this is the value of 6 decile, that is D6. So here the D6 is equal to 28.4. Okay, now see the last D9. For finding the D9, put I is equal to 9 in the formula. What is the formula? Di is equal to I in bracket n plus 1 divided by 10th observation. Okay, so I 9. So 9 into n plus 1 divided by 10th observation. Now put n value is equal to 15 in the formula. So 9 into 15 plus 1 divided by 10th observation. So 15 plus 1, that is 16. 16 divided by 10, that is 1.6. So 1.6 into 9, that is 14.4th observation. So how to find out the 14.4th observation? So this 14.4th observation is written as 40 plus 0.4. So first it is 14. So 14th observation plus remaining part as it is 0.4. After the 14th observation there is the 15th observation. So 15th minus previous, that is 14th observation. Now just plug the values of 14th observation, 15th observation in the formula. So which one is the 14th observation? So 14th observation is 49 and plus 0.4 as it is into in bracket. Which one is the 15th observation? 60. So 60 minus 49. Okay, now the next is 49 plus 0.4 into 60 minus 49, that is 11. So 11 into 0.4, that is 4.4. So last 49 plus 4.4, that is 53.4. So this is the method for calculating the deciles for ungrouped data. Now see case 2 for group data. So how to calculate the deciles for group case? First step is to calculate LCF, that is less than cumulative frequency. Now the second step is calculate IN divided by 10, where capital N is total frequency. And what is the values of I? The values of I are 1, 2, 3 up to 9, because there are 9 deciles which divide the data into 10 equal parts. Now the last step is see the LCF just greater than IN divided by 10, then corresponding value of X is ith decile. Okay. Now see example. Calculate deciles D1, D4 and D8 for following data. Here the data we are given the class X along with their frequency, that means the given data is group data. So how to calculate the deciles for group data? The first step is to calculate LCF, that is less than cumulative frequency. The next step is to calculate IN divided by 10. And the last step is see the LCF just greater than IN divided by 10, then corresponding value of X is your ith decile. Now see first calculate LCF, that is less than cumulative frequency. So how to calculate less than cumulative frequency? Write down first frequency value as it is. So 2 as it is. Then 2 plus 5, that is 7. Then 7 plus 7, that is 14. Then 14 plus 13, that is 27. Then 27 plus 21, that is 48. 48 plus 6, that is 54. Then 54 plus 8, that is 62. And last 62 plus 3, that is 65. And here the capital N value is 65. That is total frequency. Now see how to calculate D1. For calculating the value of D1, put I is equal to 1. So the first step for calculating the deciles is to find out the values of LCF. The next step is to calculate the value IN divided by 10. For calculating D1, put I is equal to 1. So 1 into, what is the capital N value? 65 divided by 10, that is 6.5. Now see the LCF value just greater than 6.5. So here which LCF value is just greater than 6.5? Here the LCF 7 is just greater than 6.5. So the corresponding value of x is first decile. So our D1 value is 7.5. Okay, now D4. For calculating the value of D4, that is 4 decile, put I is equal to 4. So IN divided by 10. What is the value of IN divided by 10? 4 into 65 divided by 10. That is 26. So which LCF value is just greater than 26? Here the LCF 27 is just greater than 26. So the corresponding value of x is 4 decile. So here the D4 value is 17.5. Now the last D8. For calculating the value of D8, put I is equal to 8. So IN divided by 10. So I is 8 and is 65 divided by 10. So the value is 52. Now see which LCF value is just greater than 52. Here the LCF value 54 is just greater than 52. So the corresponding value of x is 8th decile. So D8 is equal to 27.5. So this is the method of calculating the deciles value in group case. Now see third case, continuous data. So how to calculate the deciles in continuous case? So first step is to calculate LCF, that is less than cumulative frequency. Now the second step is calculate IN divided by 10, where I values are 1 to up to 9 because there are 9 deciles, and capital N is total frequency. Now the last step is see the LCF just greater than IN divided by 10, then corresponding class is ith decile class. So how to calculate deciles? The formula is Di is equal to L plus IN divided by 10 minus CF upon F into H, where L is the lower limit of ith decile class, F is the frequency of ith decile class, CF is the LCF value before ith decile class, and H is the class width of ith decile class. Let's see example. Calculate the deciles D1, D2, D3 for following data. The data we are given the classes along with their frequency. That means the given data is continuous data. So for finding the deciles in a continuous case, first step is to calculate the LCF, less than cumulative frequency. The next step is to calculate IN divided by 10. And the last step is see the LCF just greater than IN divided by 10, then corresponding class is ith decile class. And by using that ith decile class, the formula for calculating the deciles is Di is equal to L plus IN divided by 10 minus CF upon F into H. So first calculate LCF. So how to calculate LCF? Write down first frequency value as it is. So 12 as it is. Then 12 plus 22, that is 34. Then 34 plus 28, that is 62. Then 62 plus 38, that is 100. 100 plus 37, 137. 137 plus 29, 166. 166 plus 20, 186. And 186 plus 14, that is 200. And here capital N, that is sum of column of F, that is total frequency value is 200. Now first calculate the value of D1, that is first decile. So for calculating the value of D1, put I is equal to 1. Okay, first calculate IN divided by 10. So I is 1. So 1 into 200, capital N value is 200, divided by 10, that is 20. Now see the LCF value just greater than 20. So here which LCF value is just greater than 20? Here the LCF 34 is just greater than 20. So the corresponding class is first decile class. So our first decile class is 2 to 4. Okay. Now here the formula is Di is equal to L plus IN divided by 10 minus CF upon F into H. Now just put I is equal to 1. So D1, okay, is equal to, what is the value of L? L is the lower limit of first decile class. So what is the lower limit of first decile class? It's 2. So 2. Then in divided by 10. So in divided by 10 value is 20. So 20. Now CF. What is the CF? CF is LCF value before first decile class. So here the LCF value is 12 before the decile class. So put the value 12. Now F. F is the frequency of first decile class. What is the frequency of that class? 22. So 22. And now last H. H is the class width of decile class. How to calculate the class width? Upper limit minus lower limit. What is the upper limit? 4. And what is the lower limit? 2. So 4 minus 2, that is 2. So 2. Now in next step 2 plus 12 minus 20 minus 12, that is 8, divided by 22 as it is, multiply by 2. Now 8 divided by 22, that is 0.3636, multiply by 2, that is 0.7272. Then 2 plus 0.7272, that is 2.7272. So this is the value of first decile. Now see how to calculate second decile. For D2, just put I is equal to 2. So in divided by 10. So I is 2. So 2 into 200 divided by 10. So value is 40. Now see the LCF value just greater than 40. Here the LCF 62 is just greater than 40. So the corresponding class is second decile class, because here we are finding the value of D2. So second decile class is 4 to 6. So the formula for calculating the deciles is di is equal to L plus in divided by 10 minus CF upon F into H. Now put I is equal to 2. So D2 is equal to, what is the value of L here? L is the lower limit of second decile class. So lower limit is 4. Now in divided by 10 value is 40. Now CF is the LCF before second decile class. So which LCF value is before decile class? 34. So 34. Now divided by F. F is the frequency of second decile class. So frequency of that class is 28. And H is the class width. How to calculate the class width? Upper limit minus lower limit. Here upper limit is 6 and lower limit is 4. So 6 minus 4, that is 2. Okay, now in next step 4 plus 40 minus 34, that is 6. Divided by 28 as it is, multiply by 2. Then 6 divided by 28, that is 0.2142, multiply by 2, that is 0.4284. And 4 plus the 0.4284, that is 4.4284. So this is the value of second decile, that is D2. Now the last D3. So for the value of D3, put I is equal to 3. So in divided by 10, that is 3 into 200 divided by 10. So the value is 60. So see the LCF just greater than 60. So here the value 62 is just greater than 60. So the corresponding class is third decile class. So our third decile class is 4 to 6. Now formula is di is equal to L plus in divided by 10 minus CF upon F into H. Put I is equal to 3. So D3 is equal to, what is the value of L? L is the lower limit of third decile class. What is the lower limit? 4. Okay, what is the in divided by 10 value? In divided by 10 is 60. So 60. Now CF, what is the CF? LCF before third decile class. So which LCF value is before that class? 34. So 34 divided by F is the frequency of third decile class. What is the frequency? 28. And H is the class width. How to calculate the class width? Upper limit minus lower limit. So upper limit is 6, lower limit is 4. 6 minus 4, that is 2. Now next 60 minus 34, that is 26, divided by 28 as it is and multiply by 2. Then in next step 26 divided by 28, that is 0.9285, multiply by 2, that is 1.857. Then 4 plus 1.857, that is 5.857. So this is the value of D3. This is the procedure of finding the deciles in continuous case. Now see how to calculate the deciles by using graph. To find out the deciles by graphically, we use the ogive curve. There are two types of ogive curve, less than ogive curve and more than ogive curve. Here I am using the less than ogive curve. How to draw the less than ogive curve? Take upper limit, that is upper class boundary on x axis and the LCF value on y axis, and plot the points on xy plane and join these points by the smooth curve. The graph is called as the less than ogive curve. But one condition is that to draw the less than or more than ogive curve, we need the classes is in exclusive form. Our the classes is already in exclusive form, so no need to convert it. So take upper limit, that is upper class boundary on x-axis. What are the values of upper class boundary here? In first class, what is the upper limit? 2. In second, 4, then 6, 8, 10, 12, 14, and last is 16. Now take upper limit on x-axis and the LCF on y-axis. So upper limit on x-axis and LCF value on y-axis. Now plot the points. For the upper class boundary 2, what is the LCF value? 12. Then for 4, it's 34. Then for 6, it's 62. Then for 8, it's 100. Then for 10, it's 137. Then for 12, it's 166. Then for 14, it's 186. Then for 16, it's 200. Now join the points by smooth curve. So this graph is called as the less than ogive curve. Now how to calculate the deciles by using the less than ogive curve? See, for D1, what is the value of IN divided by 10? It's 20. For D2, what is the value of IN divided by 10? It's 40. And for D3, what is the value of IN divided by 10? It's 60. Now see the points 20, 40 and 60 on y-axis. So here the point 20, then 40, then 60. Now draw the horizontal line up to the curve. And wherever the line, horizontal line touches on the curve, from that point draw the perpendicular bisector on x-axis. And this point of x-axis where the perpendicular line meets on x-axis, this point is your deciles value. So here D1, then D2 and the last is D3. So this is the method of calculating the deciles by using the graph. Now last, merits and demerits of deciles. The merits and demerits of deciles is same as the median and quartiles. Merits of deciles are, it is simple to understand and easy to calculate. It is calculated by graphically, yes, by using the less than ogive curve and more than ogive curve. Then third, it is least affected by extreme observations because it does not depends on all observations. That's why it is least affected by extreme observations. Then it is calculated for qualitative data, that is in group case, and it is calculated for open-end class also. Now the demerits of deciles are, it is not based on all observations, and if it is not based on all observations, then it is not rigidly defined, and that's why it is not capable for further mathematical treatments. These are the merits and demerits of deciles. In next lecture, we will see the next measure of central tendency, name is percentiles. Thank you.